Welcome to week 3 of Design and Development of Educational Technology. This week, we'll be exploring the idea of active learning, a term that encompasses many forms of engaging students with their own learning. We'll talk about how the choices we make as designers can have a real influence on how people learn, emphasizing the important need to give learners control and autonomy, along with an opportunity for reflection. In your assignment at the end of the week, you'll have an opportunity to revise your pitches to incorporate these ideas, making them even more dynamic and engaging. Now, we saw a lot of great pitches and supportive dialogue in the forum so far, so keep up the good work. Your imaginations are really working overtime, and we appreciate how seriously you're taking the course material. Okay, so what do we mean when we talk about active learning? As I mentioned, this is a term that describes many different kinds of learning activities. Throughout this week, we'll hear from experts who are developing technologies using different forms of active learning. As opposed to the lecture-style teaching, students doing active learning take responsibility for their own learning. They engage in activities where they do things and think about those things as they do them. While there is a range of research and theory that focuses on active learning, the main idea is that the students are autonomous. This means that they are doing work on their own, learning or creating because they are invested in the topic they are working on. If students are motivated to learn, possibly by answering questions they have generated themselves, they are more likely to do the hard work of ensuring they fully understand something. As an example, let's think about cells. Every intro biology student learns about them, but how do they learn? Well, they could certainly read about the structure of a cell or be told about it by an expert. Many of you probably learned cell biology this way. And do you remember much about it? Maybe or maybe not. I know for a lot of people that type of information vanishes quickly, just long enough to take a test. I would call it passive learning, because the learner is simply sitting there taking in information. Now let's think about what other ways there might be to learn about the structure of a cell. Lots of biology teachers and students get pretty creative when it comes to this particular topic. Students could make a poster of a cell. That's slightly more active. Or they could make a 3D model. It could be a knitted cell, or a cell made of candy, or even a whole cell cake. Think about all the details one would have to pay attention to in order to make that cell cake. What should the organelles be made out of? How big should the nucleus be? How thick should the cell wall be? As these questions come up, students have to research to find the answers and then use those answers in their cell designs. Similarly, students could role-play as cell repair engineers and be tasked with repairing damaged cells. Or they could even orchestrate a cell flash mob. Think about it. To choreograph something like this, they'd have to understand the parts of a cell as well as how they move and work together. And they'd have to understand it well enough to direct the actors, which would involve some reflection on what they know and what they don't know yet. So these are examples of active learning. Students are motivated because they have autonomy, freedom to make decisions. Those decisions might be about materials to use, ways to act, or methods they use when they solve a problem. Students who are actively engaged in their learning develop deeper understanding and remember what they learned longer. There's a reading from this week from the Proceedings of the National Academy of Sciences. It's a meta-study that looks at data across hundreds of studies and finds that students who learn actively perform better. While there are many forms of active learning, we're going to take a deep dive into 3 related topics this week that I think are particularly relevant and also interesting. Learning with and from simulations. Building and using simulations can be a great way to explore concepts and phenomena in active ways. We'll look at how teachers and students use some simulation software and what it lets them do. Constructionism and creativity. When they're making work that's personally meaningful to them, people are more engaged in their own learning. Tools that foster that kind of creativity are very valuable, not to mention fun. So we'll take a look at some examples of creative learning technologies. Designing for non-cognitive skills. These are skills like persistence and grit. They're not the things that directly help you learn content, but they are necessary for success in any kind of endeavor. We'll hear about what non-cognitive skills have to do with learning games and educational technology more generally. By looking at each of these concepts and examples of educational technologies, I think you'll get a pretty good idea about why active learning is so important and how it's different from some traditional forms of learning. Hopefully, you'll also get some ideas for ways to incorporate active learning and reflection into your own pitch.